Hello and welcome to lesson number 2 on fractions. Notice on top it says multiple times, no calculators, no calculators, no calculators, do it without a calculator. You cannot have a calculator when we are going to be assessing on this. So the sooner you learn how to do this without a calculator and ease into it, the better off you will be when you take assessments. So it does also say to leave answers in exact form and don't forget to reduce. Exact form means you are not writing your answers as a decimal, that you are rounding, because as soon as you round a decimal, it is no longer exact. Now, if the decimal is a half, which is written as 0.5, and you don't have to round that, that is okay as an answer. But just to be safe, I think for this section in this lesson, leave all your answers in fractional form. All right, so the first thing I want to mention is when you're adding or subtracting fractions, you do need to have a common denominator. The denominators have to be the same. So if they're not, you are going to have to rewrite one or both of the fractions so that they do have the same denominator. When you're multiplying and dividing, you absolutely do not need to have a common denominator. You just need to do one of two things. All right, so for our first example, we have 11 over 12 minus 5 over 12. Now, because the denominators are the same, I am ready to do this problem. So here, the whole reason we need the same denominator is because that kind of carries over. If I have 11 twelfths minus 5 twelfths, that is going to equal, and I just worry about the numerator, 11 minus 5 is 6 over 12. 6 over 12, because both of these are divisible by 6, I can reduce this fraction, and it is going to equal 1/2. And that is my final answer. For number 2, we are now multiplying the two fractions because there's a dot in between. So when we multiply fractions, you have two choices, two ways you can do this. You can multiply across on top, 6 times 5 is 30, and then you can multiply across on the bottom and you get 72. Now, without a calculator especially, if you see that you could reduce this, I see that we could divide top and bottom by 2. Maybe something bigger, we'll see. We're going to get 15 over 36. Now, I see that 15 and 36 are both multiples of 3, so I could divide both by 3, giving me 5 over 12, and then 5 and 12 have no other factors in common, so that will be my final answer. Now, another way that you can do this problem, I'm going to rewrite it over here. 6/8 times 5/9. So what I did is I multiplied here. First I multiplied, and then I simplified. Okay, so I took out common factors from numerators and denominators. What I'm going to do this time is the reverse. I'm going to simplify first, and then I'm going to multiply. So when you're simplifying, you're looking between numerators and denominators, is there a certain factor that you could take out? Now, it could be a numerator and denominator in the same fraction, or it could be in different fractions. So what I mean by that is, like here, 6 and 8, I could reduce both of those by 2. Another thing I notice, 6 and 9 going across diagonal, those also have something in common. They have a 3 that I could factor out. It really doesn't make a difference which way you do this. So say I did 6 and 9. They both have a 3 in common. So 6 divided by 3 is 2. 9 divided by 3 is 3. And now I would multiply across. However, before I do that, I still notice I have 2 and 8. 2 goes into 2 once, and 2 goes into 8 4 times. Multiplying now across, I have that 1 right here. This 1 times 5 is 5. 4 times 3 is 12. And notice that my answer is the same. Now, tomorrow in class, maybe we'll go over showing you if I had simplified 2 and 8 first versus the 6 and 9 diagonal. Now, if the numbers are small, it does make sense. I mean, you could do it either way, multiply then simplify, or simplify then multiply. But if the numbers are huge, like if you're going to have to multiply 72 times 56, let's say, probably look to simplify before you multiply. Okay, now number 3, we have 3 fractions, and the first are being multiplied, the second two are being divided. We have to follow the order of operations. Please excuse my dear Aunt Sally or PEMDAS, however you learned it. Now, multiplying and dividing is what we're doing here, and notice that we do multiply and divide left to right, so whichever comes first. That's the order of operations. So I'm going to multiply first. But I am going to rewrite this because when you are dividing fractions, so I have negative 18/12 times negative 7/11 slushies. Now, the division symbol, when you divide by a fraction, that is the same thing as multiplying by the reciprocal. The reciprocal of a fraction means you are going to flip the numerator and the denominator. You're going to flip that fraction. So right here is a perfect example of if I didn't have a calculator, if I had to do negative 18 times negative 7 times 12, could I do it? Yes. Would it take me a bit of time? Yes. So what I'm going to look for is those numerator-denominator combos that I could simplify. For me, the first thing I notice is I have a 12 here and a 12 there. They go into each other, I'm left with 1. Already this looks so much better because now in the numerators I have negative 18 times negative 7 times 1. That's a lot easier to do. However, I also notice I have this 9 and 18. So they are both divisible by 9. So this would be a 1 and this would be a 2. I look and see what I have left. I have a negative 2 in the first fraction's numerator, then a negative 7 in the second fraction, then a 1. In the denominators, I have a 1, then an 11, and then a 1. There is absolutely nothing that I could simplify further than what I've already done. So I have to be careful because when you start, crossing out and doing all these factors of this and that, you have to make sure that you account for everything. So the first fraction, don't forget that negative sign in front. It's negative 2. My second fraction numerator is a negative 7. The last one is a 1. So altogether, that is a positive 14. Again, negative 2 times negative 7 times 1 gives me 14. In the denominators, I have 1 times 11 times 1. I'm going to leave that as an 11. Now, I know in middle school, a lot of times we want to rewrite this as 1 3/4, mixed numbers. Try to avoid those because when we're going to be dealing with slopes and when we're going to be solving equations, it's just easier to have an improper fraction. Improper fraction meaning your numerator is larger than your denominator. Okay, so let's apply this to solving some equations like we did in class yesterday. So the first one, I have 5 plus p over 7 equals negative 4. I have to get rid of this 5 by subtracting 5 from both sides. P over 7 is going to equal negative 9. I have to undo division by doing the inverse operation. So I'm going to multiply both sides by 7. 7 times p over 7 is the same thing as 7 over 1 over 7. Those 7's cancel. I'm left with p equals negative 63. And just like the last video, you can check your answer. Is 5 plus negative 63 over 7 going to equal negative 4? Right now we are checking. So we are seeing, is this in fact equal? 5 plus negative 63 over 7 is negative 9. When I add those two numbers, do I get negative 4? I sure do, so I could be certain that my answer is correct. All right, for number 5, I want you to try this one on your own. Pause the video, try it. I will display the answer for you after you try it yourself. All right, so the answer that you should have gotten is 29 over 7. Please make sure that if you do not get that answer on your own, you do ask your teacher in class tomorrow or whenever you see them. All right, for number 6, we have 8/5 j equals 2. If you remember, yesterday I said, okay, we have 8/5 times j. A lot of kids, students want to divide by 8/5, and then you get what is called a complex fraction over here on the right side, and a lot of times that causes a bit of confusion. So, if you recall, I said rather than doing that, let's multiply by the reciprocal of the fraction. The reciprocal of 8/5 is 5/8. You flip the fraction, that's how you get a reciprocal. So the 8's cancel, the 5's cancel, you are left with just j equals, and then on the right side, you're going to do 2 times 5/8. 2 times 5/8 is the same thing as 2 over 1 times 5/8. If that whole number times a fraction causes you some confusion, write the whole number over 1, and now you could do either multiply top times the top over denominator times denominator, or simplify the 2 and 8, but in either case, the answer that you get is going to be 5 over 4. Okay, and again, to check that, I would do 8/5 times the value of j I got, 5/4, and see, does this equal 2? Again, how you multiply the fractions is up to you. I could cancel numerators and denominators, common factors out of them, or I can multiply numerator times numerator, denominator times denominator. Simplify, don't simplify. Whoops, that goes into there once, into here twice. So your answer is 2. All right, number 7. So we have a problem here that has multiple fractions throughout. We have 5/9 u minus 3 equals 11/4 u plus 12. So the first thing I know is that we have to get our u's together. The u's have to come together on one side. Again, no calculators for this. Calculator would make this a lot easier. However, you're not going to have one at your disposal all the time. So we have to get the u's together. So I could either subtract 5/9 u or I could subtract 11/4 u from both sides. Either way, it's my choice. I am going to subtract 11/4 u. So for the first time here, we have, and I'm going to go off to the side, we have 5/9 minus 11/4. Those denominators are not the same. To add or subtract fractions, you need to have the same denominator. Now, I know I ignored the u's for now because I'm only going to worry about the coefficients. The numbers in front of the variables is all I'm going to worry about. So in order to make these the same, I need to find the least common denominator. What can I make 9 and 4 by multiplying into them? What can I make them both? What number can they equal? Hopefully you see that it's 36. So now I think to myself, what did I multiply 9 by to make it equal 36? I multiply by 4. So what I do is I multiply by 4/4. 4/4 is just a different way to write the number 1. As long as you multiply by 1, you're not changing a number's value. You're changing how it looks maybe, you're increasing its multiples, but you're not changing its value. So 4 times 5 is 20. Now I do the same for 11/4. What did I multiply 4 by to make it 36? Well, it's 9. So that number is going to be 99/36. So to combine these two fractions, I'm going to do 20/36 minus 99/36. That's going to give me negative 79/36. All right, so I have negative 79/36 u minus 3 equals 12. Add 3 to both sides. This is going to equal 15. All right, so now my last step is to get this fraction apart from the u. It's multiplying. I'm going to multiply by the reciprocal. And this actually ends up being kind of a nasty value. U is going to equal 15 times 36 is negative 540 over 79. An answer like this is going to make you think, oh, I probably messed this up somewhere along the way. Remember, plug it in, double check your answer. I just did that. I paused the video and I made sure that this was the correct answer because it does look kind of outrageous. All right, so I want to show you a way that you can, instead of going through and finding common denominators and dealing with these numbers, there's a way that if you have an equation that has multiple denominators, multiple fractions in it, I should say, you can do what's called killing the fractions. So you could go through and multiply everything in this problem. So you start off with your original problem, multiply everything by the LCD. So by everything, I mean every single term in your original equation. This equation has 5 terms. 5/9 u minus 3, that's 2 terms, 11/4 u, and 12. So when I'm looking for the LCD, you want to think and look at all the denominators, and you could put these over 1 again if that makes you feel more comfortable. So my denominators are 9, 1, 4, and 1. What is the least common denominator? It's going to be 36. And actually, I'm not going to do that way. The least common denominator here is 36. So what I do is I'm going to take this problem and multiply every term by 36/1. By doing this, what's going to end up happening when you multiply every term by the LCD is you are going to get rid of, or basically kill, every single fraction. Because here, if we have 36 over 1 times 5 over 9, 9 goes into 36 4 times. You would be left with, and I'm sorry, my room is I'm running out of room here, 20u. Minus 3 times 36 is 108. Equals, now we have another fraction. That denominator is going to go evenly into the least common denominator, thus killing the fraction. I have 99u plus 12 times 36 is 432. Now, if you're thinking to yourself, oh my goodness, these numbers are pretty big, that's going to take me a while to set up my multiplication, multiply those, we're probably not going to give you such big values on an assessment. We would give you something smaller. So now this equation in green is a lot friendlier looking than the one I had before. I bring my u's together, I subtract 20u from both sides, I have negative 108 equals 79u plus 432. Subtract 432 from both sides. And notice I'm going to get negative 540 equals 79u. Divide both sides by 79. And my answer is identical to what I got over on the left side. In my opinion, going through and killing the fractions makes the problem a lot more doable and easier to deal with, because you don't have to worry about finding common denominators and then multiplying by reciprocals and all of this. It just makes it a more simplistic problem. Again, it's a matter of preference, so whichever way you prefer. For the last two problems, I do want you to pause the video, try them on your own. Number 8 is a double distribution. I will tell you to be careful here because many times kids don't follow the order of operations and they want to write that that's 1 times the quantity 8 plus 7q. It is not, right? You're going to have to distribute first, so make sure you do that. Distribute here. And then for number 9, your choice. Either do my method that I prefer, which is multiply through by the least common denominator, and I do believe these numbers are much friendlier than number 7 above, or go through, combine by getting like terms and so on and so forth. Pause the video. I will pause mine as well, write the correct answers. If you don't get them, we're going to go over them in class tomorrow, but make sure you come with questions. All right, so for number 8, the answer that you should have gotten is Q equals 8 over 63. And for number 9, you should have gotten that M is equal to negative 13/24. If you did not get those answers, or even if you did, we're still going to go over them in class tomorrow. Okay, thank you so much. Bye.